Now, in terms of the timeline for IMT 2020, we can see here the two previous generations, the time period it took to develop 3G, IMT 2000, and 4G, the IMT Advanced. And some pretty long numbers in here, and it wasn't quite clear to me what was achieved during this 15-year period at ITU, but anyway. So this is that kind of high-level view of when so we are currently in this sort of period here, we're just in the sort of vision phase for 5G. Looking in slightly more detail, you can see some of the activities. So we have the World Radio Conference in 2015 and another one in 2019, and then various activities that are going to happen between then and now. Now, some observations on the timeline. They are going to use the same process for IMT 2020 as they did for IMT Advanced. So from that point of view, we make some observations. It took 12 years to go through the cycle for 4G. The only commercially successful 4G technology was LTE, or LTE Advanced, and it was based on a very stable LTE standard, which was only just completed. So that took 12 years, sorry. Now the plan for IMT 2020 is 8 years, and the challenge they've set themselves is hugely more complex than it ever was in 4G in terms of the scope. And also, there's no standard to sort of piggyback on. So there's a big difference in the scope. And also, on the issue of spectrum, there's no spectrum yet. And if there is going to be any, it won't show up until 2019. And then you've got the whole process of well, how do you deal with that? And maybe you need to change the design of the system based on the frequency. So basically, there's a lot of factors that suggest that significant deployment of 5G by 2020, which is the goal of some industries, is kind of unlikely. But it's the target that the industry is setting itself in order to get moving. So, question is, if spectrum doesn't get allocated in 2019, or if that's too late, is there a plan B? And this is where it gets interesting. So, there's a new work item in 3GPP called Licensed Assisted Access. How many of you have heard of it? Quite a few of you. Okay, that's good. So this is quite important. In fact, it could be the defining moment for 5G in my view. So what LAA does is it allows an operator to offload traffic onto femtocells operating in the ISM band, the 5 gigahertz band. So effectively a cellular version of Wi-Fi. So cellular technology using Wi-Fi spectrum. And this is very controversial because if you put a broadcast system like LTE into ISM spectrum, you stop the other devices from working because they're used to this cognitive way of listen before talk, and LTE doesn't do that. So there's going to be some work to develop a new version of LTE with this cognitive listen before talk ability. Then potentially LTE will be able to operate in these bands without interfering. It would just be another peer along with wireless LAN. So it's very attractive to operators that haven't already invested in Wi-Fi. So operators like Verizon, for instance, as opposed to AT&T that has a very strong Wi-Fi network. And an LAA solution in theory gives the operator more control of the user experience. And that can be seen both positively or negatively depending on how you view control. So this is what the current ISM spectrum looks like. We've got a little bit of spectrum at 2.4 gigahertz, which is basically providing the bulk of the world's wireless traffic today. Then we've got significantly more at 5 gigahertz, which is currently underused. This is 802.11ac, etc. And then on the same scale, we have the 60 gigahertz spectrum. And the good news is that those middle channels 2 and 3 are pretty much worldwide. So, huge potential here. And then just a quick look at the worldwide allocations. You can see that pretty much channels 2 and 3, you could use that anywhere in the world, and there's a few regional variations there. So, so wireless LAN is very much an active standard. Its integration with cellular is continuing to grow, and we get some quite advanced possibilities in terms of authentication and billing and all the rest of it can all be integrated. So it's certainly a very interesting area. And so in summary, so the demand for spectrum is continuing unabated. There is likely to be some new spectrum below 6 GHz allocated at WRC 15. And the predictions for what's needed here are up to another 2 GHz. That won't happen. I mean, if we get 500 megahertz, it would be a huge gain. And there's no millimeter wave spectrum being discussed in 2015. But hopefully there will be an agenda item, and that's pretty likely, I think, for 2019 to discuss the possibilities. But there will be coordinated opposition to that from all the other industries. So it's not a free ride. And then if LEA is successful repurposing the 5 GHz ISM band, then it's very likely that 60 GHz will be the next target, because it avoids all these issues with spectrum allocation and provides a very broadband, already worldwide allocated channel. So, and that would give IMT 2020 somewhere to land at the time people actually want to see 5G services. So some form of hybrid air interface between wireless LAN and cellular is likely to be developed, and I think deployed at 60 GHz before any other frequencies. So, so the good news is the future is already here. It's just not evenly distributed.
The key point about South Korea from an LTE point of view is the percentage of subscribers that have an LTE device. And 66% of people would look at that, how that compares with the rest of the world. More people have a 4G device in South Korea than anywhere else in the world. And therefore, what we tend to see is they're using those 4G devices in new ways, with, and the technology is pushing those 4G devices that way. So that's why we look at South Korea particularly. It's not the only advanced market. So you could take the US, which traditionally wasn't very strong in 3G, now has a very strong rollout of 4G. You look at Japan, very strong in 4G, but South Korea is an area, and there's quite a lot of sort of UK operators who spend time in South Korea looking at what the local operators there are doing. And so that's why I've picked particularly South Korea for today's talk. And if we look, this slide's a little bit busy, but if we look at the lead markets generally, you'll see that this is Korea, South Korea at the top, with 66% of subscribers with 4G. Just by the way, who has a 4G, I won't say a 4G phone, but a 4G subscription in the audience today? So I'm not doing the counting machine, but I would guess that's about 25%, something like that. The UK sits in here. So this is the UK as a percentage. It's not in the top 7, but I think, you know, the first time I looked at this, I thought that's very, very negative. But if you actually look where the UK is from a European perspective, it's actually one of the lead markets in the wider European piece for 4G adoption of devices. And we see that as well from a Nokia point of view. There's lots of new technology being deployed and trialled in the UK. So it sits in that middle band at the moment of subscription. And it's typically, we see things that are happening in the UK 9 months behind South Korea. That's just a very, very general. Sometimes it's 6 months, sometimes it's 12 months. But so that's the difference from the timescale. And this, I think, leads on quite nicely from the first presentation, which was really looking at the spectrum. Just to say a little bit to start with about the 3 operators in South Korea. SK Telecom, KT, and LGU Plus. When they actually launched, they each launched with relatively small spectrum. So 10 megahertz of LTE, that was the only spectrum they had available for their LTE networks. They're roughly the same size. It isn't as if you have one. And no, it's a very competitive environment. So there's lots of requirements all the time to have the latest thing so that you can then market the latest capabilities and technologies. And one of the things we've seen is essentially taking additional spectrum and using carrier aggregation. So carrier aggregation, very, very sort of technical term. What it basically means is the device will be taking its 4G data from two different frequency bands at the same time. Okay. So originally LTE 5 or 10 or 20 megahertz, but where you have the spectrum in two different bands, so LGU plus 850 and 2.1 gigahertz band, then they deployed this technology from LTE advanced called carrier aggregation. And carrier aggregation, your phone, if it supports carrier aggregation, gets its data from these two spectrums at the same time. And this is a situation that we have, I think this is very much today, where all three operators have deployed carrier aggregation in their network. A mixture of frequencies, this was pointed about the different combinations, that hasn't actually turned out to be too much of a problem in practice, having lots of different combinations of spectrum and frequency bands. It's a pain from a testing point of view, but technically it's just a matter of making sure you have the right equipment on the sites. So we have SK Telecom with 10 megahertz and 20 megahertz carrier aggregated, KT with 20 and 10 the other way around, and then LGU plus having 10 plus 10 plus 20. So they're the first operator that's actually been able to do carrier aggregation with 3 bands of LTE spectrum. And that's now, I think commercial first devices are just available with that. Looking forward, you can see that the point about the 3G traffic now going down allows operators to start refarming some of their traditional 3G spectrum at 2.1 gigahertz to the 4G spectrum. So it just becomes LTE in the same spectrum band as it was 3G. So we call that refarming. So we have the next development for SK Telecom is to start using the wideband CDMA 2.1, and you can start to see that all the operators will pick up more of their FDD spectrum in the 2.1 gigahertz band. And then they also have, 2 of them have spectrum in the unpaired spectrum, so it's available for TDD, LTE TDD technology, and they'll start to deploy TDD technology in that band. And although the marketing here, so you see the launches of this for these, this was June 19th this year, June 26th, June 30th. You can see they're all very aligned in terms of their launches of this kind of thing for LTE Advanced. Although the main driver marketing-wise is the 225 megabits per second, so this is the peak rate story from a marketing point of view. In reality, it's all about capacity. So if you have more spectrum, and you have 4G, you can handle that capacity, you can handle more users, giving them a bit rate of 15 to 20 megabits, which is perfect for most mobile applications. So how do you position that with the UK? The UK actually was quite advanced in this. BE announced their carrier aggregation last year, and Vodafone now have carrier aggregation in the network. So we've seen carrier aggregation coming in some cases 20 plus 20 and 20 plus 10, so we have that in the UK.
The position or the view that we have is that LTE will provide the future solution for mission critical broadband data. So that's important point number 1. Okay. With standardization, which is a really important part, it could also provide the answer for mission critical voice. So 2 bold statements, and what are we doing about it? We're actively supporting the standardization process, and we're bringing our long experience of mission critical user requirements to that process to help, and we're in this for the long term. Let's just sort of summarize where the mission critical user looks across the current technology portfolio that's available. So we're in the business of Tetra, which is the current de facto choice for mission critical users, or has been for the last decade or so. But there are other things out there like DMR, digital mobile radio, which we're also involved in, Tier 3 trunk, Tier 2 multi-site IP, Tier 2 single site. You can see how those layer against the user groups. But I'm really, for purposes of this discussion, going to zone back up to mission critical user segment. Again, I think Tetra remains a very valid, viable, and even evolving standard, which can be used not only for voice, but also for data, and we have great examples of that, but we also believe other barriers can come into play as well. So, looking at some of the mission critical requirements, this is not an exhaustive list. This is my attempt at trying to pull a few of the real key things out into a slide. Mission critical users continue to rely on a global, evolving open standard. That's really important because it provides safe functionality and choice, and probably good value as well. The other thing that mission critical users rely on, and has been much debate recently around LTE, is ruthless preemption prioritization and the ability to do one-to-one and one-to-group and group-to-group type communications. That's really quite important. A recently retired chief constable said to me, without voice, there is no policing. So we've got to try and remember that. And then try to work out ways where police can harness the use of mobile broadband and higher speed data solutions as well. But these are some of the things that apply, so some of the really important things that we've got to consider. Picking out some other things here. Security is mission critical, as you would expect. End-to-end encryption solutions are required for both voice and for data. Graceful degradation is something that we're particularly comfortable with and used to in Tetra, and it's really important we make provisions for that when we look at the use of mobile broadband as well. This system needs to keep working. The mission critical user is the summary. Now, this is probably the slide that I've used quite a lot in a number of different audiences, and it's probably where I get closest to a sales pitch. But the key message that I make to people is that you can actually invest in using data today. You don't need to wait for all of the stuff around standardization. You can use Tetra today, you can use 3G today, you can use 4G LTE today. It's about using it appropriately and in a multi-bearer environment, perhaps. The real important thing, though, and often the limiting factor, is not technology. Technology evolves, becomes standardized, gets deployed, is innovative, all of those things. Often the challenge in the mission critical environment is actually around procedural things and legislation. So, to give you an example, a little bit close to home here, well, certainly in Greater Manchester, the police a couple of years back decided that they would like to change the way they used stop and search. So they used to fill out a very long, complicated, carbonated triplicate form, which was rather inefficient, and we worked with them to try and come up with an electronic or some technology. That was the easy bit. The hard bit was changing the legislation provision in the Police and Criminal Evidence Act. That took time. So we have to be mindful of that, and we've got to understand the challenges that can slow things down for the mission critical user.
Studies, I think, highlight the economic impact of decisions that national governments have to make about the award of spectrum. So the impact is potentially substantial. Potentially, it's mainly due to the significant reliance of mobile networks in today's society, and mobile broadband services in particular. So the study wasn't primarily about how mobile data is growing, but this is an example on this slide. It just shows you, for example, in China, making networks more dense and multi-layered using potentially small cells, etc. All of these developments require sufficient spectrum in order to deploy them, and this was one of the key themes of the study, that the World Radio Conference in 2015 will decide on bands that are needed for future mobile communications, and this is largely talking about meeting market needs in the mid-term, if you like, rather than the sort of longer-term 5G implications that you were talking about, Maury. So essentially what we're talking about at WRC 15 next year is identifying bands that might come into use within, say, the next 5 to 10 years. Markets. And I think one of the interesting things that we found in this study, based on data that Huawei provided for networks that they are involved in, is that although 3G to 4G migration is actually happening in many markets and operators are launching LTE and LTE Advanced, the use of 3G networks is actually still growing alongside that. So that suggests that potentially in some markets there may have been a congestion issue on 3G networks. So as users are migrating from 3G to 4G, then the remaining users on the 3G network are actually consuming more data, so they're using the networks more often or for more sort of data intensive applications. And that's why, as you can see on this slide, 3G downlink traffic has actually increased even after this same operator has launched LTE. So I think, I appreciate that there are different viewpoints on this in the market, but I think it's not homogenous. I think different markets have quite different trends in this area. So the study also looked at how 4G technology is evolving. So we've heard that speeds are increasing due to technology advances, increases in carrier size, and LTE advanced carrier aggregation being one of the key developments. So I think a few speakers this afternoon have described this, but although some of the initial LTE advanced deployments use 2 carriers for aggregation, so 20 plus 20 for example, I think we're going to start seeing 3 carriers, 20 plus 20 in the market, and then potentially up to 5 carriers, 100 megahertz being needed to do the sort of maximum of carrier aggregation which we standardised at present. So immediately you can see the sort of spectrum impact that has for operators, that they have to have sufficient spectrum available in order to yield the full benefits of these standardisation advances. Interestingly, I think operators are also investing to improve speed and coverage of 3G networks. And in actual fact, in some markets, they're also improving 2G technology as well, which potentially is interesting given the presentation we heard earlier about IoT 2020 coming into the market in 5 or 6 years, when we're still investing in 2G. But anyway, certainly in a number of markets there are key developments taking place to improve the performance of 3G networks and also to overcome some of the congestion issues. So UMTS 900 is a key technology that has seen swift adoption in many markets. It's key to relieving congestion. It also critically improves 3G coverage as well. The other thing that the study looks at is, as well as introducing new technology, one of the other benefits is that operators are able to offer new services. And I think we've already heard of some of these services today, so I won't focus on this, but in particular in the Asia Pacific region, things like voice over LTE is now being deployed widely, and also various IP-based video streaming technologies. And a good example, I think, is Huawei is working with China Mobile to deploy technology which improves video experience through optimization deployed in the core network. I know that there are other ways of doing that, and Nokia, I think, have another solution where it involves local caching at the base station. So interesting that I think there are a number of different ways that vendors are looking at optimizing these video services.